Welcome everyone online and here in Ballroom A. This is the TypeScript SDK by Gino. Gino, please, go ahead.
Thank you, Reed. Hi, everyone, especially those online. I can't see any of you, so welcome, and I'll trust that you're there by the number on the screen. I'm going to talk about TypeScript SDK today. It's kind of early in development still in beta, but I've been annoyed that there wasn't one, and I assume everyone else working in TypeScript or JavaScript has been too. So, hey, let's do something about it. Minutia, that link aka.ms/devdays-gino, that's on the slide, has all these slides and years back as well, and then they should be as handouts in Hoover as well. So if you need any of the links in later, they are there. The quick TLDR about me, I'm a software engineer at Microsoft. I'm in the research working on standards and interop. So I get to do lots of fun infrastructure and tooling and code generation and all kinds of fun stuff like that. There's contact info for me. Email, Zulip is definitely the best place. There is a specific JavaScript stream that we use for all the TypeScript stuff too, because JavaScript and TypeScript are such close friends. And then YouTube channel where I put FHIR educational content as well. So the quick disclaimers. I'm not a lawyer, but I am married to one. So for reference, this is work in progress. We are definitely not at 1.0 yet, so there will be breaking changes. And really, I also want to emphasize this is another tool in the box. I know earlier, Brian Caney did a presentation on the definitely typed things, which actually I work with him to publish. So those aren't going anywhere. We're still supporting those. There's no plans to get rid of them. But we also recognize the limitations of them. And so this is just another piece of the puzzle. So what is that piece? Really, it's just the idea of having a generic FHIR SDK that works at runtime. For anyone who's developed in any other language, you're probably used to using the happy classes in Java, or the FHIRly SDK in .NET, or the Swift libraries, or the Python libraries, or anything else. And there's been nothing in JavaScript. And really, it's just about separation of concerns. If you have done any development in these, I'm sure as developers, you wrote all of your utility functions and your shim functions and everything else. And then on project 2, you copy and pasted that code forward and kept doing that on project 3 and 4. And then you made some changes. And when you had to go back to 2, you went and copied the one from 4 back to 2 and all that fun stuff. And yes, we all do that. Yes, I've done the same thing. That's kind of what started this project, actually. So overall, let's see if we can improve the developer experience, make it a little better to work with, a little more reliable, and kind of lower the bar. If you're just trying to write a TypeScript application to do something, you want to write your application and do it. You don't want to worry about all these other things. So there it is, FHIR TypeScript. The source code is all on GitHub. Right now, we're just publishing the R4 version of core. All the code generation works for DS2.2 all the way through the CI builds of R5. But we said, let's focus on one first, just as far as getting all the build process, all build pipelining and testing and all that kind of stuff, infrastructure in place. So other ones will be coming shortly. It also has example code. We have examples written in obviously in TypeScript, but we have a project in Deno, a project in Node, and a project that's a React app. So we build all of those to make sure that our compiler settings are happy across all of them. At some point, we might have to fork the Deno one just because there are a few inconsistencies that I don't like. But if and when we do that, we'll just publish another set of packages for that. Right now, it's all ESM. We can do CommonJS. We tested and made sure it works, but we don't want to publish another set of packages if we don't need them. So if the community says you need them, we're happy to do that. But if you don't need them, we are even happier to not do that. So minutia on the project, everything's on GitHub. We're doing mono repo style because That's just easier to manage for this. It's all open licensed, MIT licensed, so public, private, open, closed, whatever you want to do, you can do with it. There's a mix of the generated code and handwritten code because not everything can be generated. And there's the infrastructure stuff. We're using rushjs.io to manage multi-build and versioning, all that kind of stuff. PNPM, so you don't replicate modules across all of your repos, all that kind of stuff. And then we package and ship it up into NPM. So what is in the box? There's a few things. First is a whole bunch of TypeScript, JavaScript classes. And these are actual classes so that they operate at runtime. There's obviously a performance penalty and a size penalty that you're paying for doing that, but that's the only way you can enforce anything. So it has all the primitives, complex types, resources, backbone elements, all that kind of stuff. All of them can parse JSON and serialize back to proper FHIR JSON. So that's interop right out of the gate. And there is this, what we're calling basic validation or model validation. And that's to say the eventual goal is to get to everything short of a terminology server. But as far as saying you have required elements, you have the right types, you have the right value set bindings, all that kind of stuff, we're hoping to get all that in. Some's there, some's in progress. There's also the value sets. All the value sets that have expansions, we include in here as well. That's one of the annoying things I always found when I was writing a UI is I want a drop-down box with my codes. How do you get them? So put them in. That's how you get them. So we have codes, codings, codable concepts. Depending on how they're defined and how they're used, you can access all of them. We put links, which we'll show in a second here, so you can actually use the object type. So like patient gender is bound to the administrative gender value set, but we also have the patient type dot gender required code, and that returns the same value set so that you can just access it that way and you don't have to actually go to the spec and look up what the value set is. And then we also have the JSON definitions in here, slightly different from the ones that are indefinitely typed, just because they haven't been through some additional packaging steps. But in order to make sure that you can work with the JSON ones prior to or post serialization and parsing, you can do all of that as well. As I said, there's example projects trying to show the different functionality, test all the build systems, all that kind of stuff. So some tricky spots. This is always a lot of fun, and we'll go through some example code here. But a lot of these things don't end up biting you until they do, if you haven't been doing a lot with this. And so primitives and extended properties is one of them. So in JSON, the primitives and extended properties like extensions are sibling elements. And I don't know if this is big enough to see. We can make it even bigger. So we can see like here, we have a patient, and in JSON we have family, and an extension on that is in this other element, underscore family, right next to it. So if you went and deleted, for instance, your family, well, you still have the extension unless you remember to go delete it too. Same thing when you go to read it, you need to read the family, and if you need to look for extensions, you need to remember to check this other element at the same level. That's pretty annoying. And so is the Zoom thing. There we go. Sorry, Zoom has all these overlays that you can't see there. Perfect. So what does it look like when we do things like this? So here we can see we're just using FHIR TypeScript R4 core. Again, we're hoping to eventually add IGs to this, and we'll get to that later, but so that you can get IG-specific things in there nicely. But we have a bunch of different namespaces. In this case, I'm using the FHIR, which are the main classes, and the FHIR JSON, just because I want to show some of the differences. So the FHIR JSON look like the ones that you'll see indefinitely typed. You know, if you want to add a name, you know, the first thing you do is check to see, well, does it have a name? If not, I have to create an empty array to use because all of the fields are nullable because it's an optional element. Then you can push a name, and then if you want to push an extension, same thing. You can go through and look at the name, hope the name exists. We know it does in this case, so we can null coalesce it and add our extension. However, we can also now use classes. So we can see here we're creating a FHIR patient. We don't have to do any of the stuff like the tags for the resource type or anything like that because that's all built into the classes. We can add human names. We can add FHIR strings that have values and extensions. We can even do things in a more fluent way. So we can say that we're pushing a human name and then we can add extensions to it. And we can actually come here and keep adding more extensions. And we get all the nice type hinting and everything else that we get because we're using TypeScript. So that's kind of the flavor of what we're trying to do with this. It does get even more interesting when you talk about arrays of primitives and extended properties, because that's even worse. Just to show the example, you have the same thing. The given name is an array instead of family name that's just a scalar value. And you can see that we have given one a null, which is supposedly not allowed in FHIR, except for when it is, and then the third given name. The reason this is allowed is because this element, the second given name, has extensions but no value. And in an array, we have to make sure that the elements line up with each other. So in JSON serialization, you're allowed to put nulls in arrays if they are primitives or extensions, because you have to make sure that those indexes align when you go back to read the data. So the same thing, we can come through here and we can say we have, the null for the first one because it had no extensions, start adding extensions, and it's a little hard to count in this format, but you can see we actually have one extra just extension. And that's because something else you can do is you don't have to write this last null. The arrays can be different lengths if that array doesn't have any more values coming after it. So, we're getting short on time. I forgot how short this talk was. That's fine. So we'll jump through a few of these things a little faster though. So same type of thing here. We can see the example using the definitely typed version or the JSON version, which is to say we still have to manage all of these separately, and we have a lot of null coalescing that we have to do. In the classes, all of the arrays always exist, so you don't have to worry about them being null. You can just check their lengths. And we can manage all of the primitive types with their extensions. So we can create a name that just has a value. We can create a name that has a string with no value and an extension, and ones that have both, or again, keep going and adding all these different things back and forth. What's nice is, again, now that we have one object type in the array, and it's one array, if you want to remove an element, you can just remove it. Or if you need to sort them or anything like that, sorting is another fun thing that you have to remember to manage both sets of indexes when you update them otherwise. So all kinds of gotchas that, again, you don't see them until they're very painful for you at some point in the future. And then the last one here, the note, just FHIR plus JSON versus the browser. This is something when you talk about like trailing zeros in a float, they're considered insignificant in most browser implementations. I do note that we haven't actually fixed that one yet because we need to finish the custom JSON parser that reads the whole file directly. But those are the kinds of things, and that's why this is marked beta. Choice types, same type of thing. You're mixing structure and type info, so you have value string versus value integer. You have types that overlap, like value date time, value canonical, URI, URL, all these kinds of fun things that you happen. Since we are now strongly typed with classes, a lot of that annoyance goes away. And I'll skip the JSON one because I think we all know what that looks like. But we can see we have, deceased is a single element, and we can put in a FHIR Boolean or a FHIR date time, and we can even move the extensions around between them because that's another annoying piece of bookkeeping. If you're going to change from deceased Boolean to deceased date time, you need to remember to look for all the extensions and copy them over to your new element. Even though it's the same element, in a choice type, it is not the same element. So lots of those little nitty-gritty details. And yeah, just overall, there's a lot of bookkeeping and a lot of tedious things that you're checking one of a lot of times to see if anything is present. Extensions have all of those in combination because extensions have choice types that can be primitives and can have extensions inside them and nesting and all those things. So we tried to make sure that there's a lot of, oh, I didn't put a nice example for that one here because it's in the other one. But as I was mentioning, there's a lot of fluent type things that we can do. Oops, too big. That when you want to go and add extensions, and this is just from one of the sample apps that's there, so that you can go through and see all of the different functionality. But you have extensions that you can go and add extensions fluently, remove extensions, search for them, so you can do like find extension, you can do filter extensions, all these things based on URLs. And we have the same types of things in, for instance, codings, so that you can add a value to your codable concept without all the annoyances of managing that array yourself. So yeah, lots of stuff like that. The value sets, oops, wrong one. As I mentioned, value set binding. This one, I'm using adverse event because this is something that even surprised me when I started working on this project, which I've been doing FHIR for several years now. But codable concepts can also have required bindings. And it's a fun little thing that you can do. Adverse event does it. So they have a required binding on severity, so that you say it has to have one of our approved severity things. But you can also add additional ones because it's a codable concept. So it's kind of this middle ground between a code, which is only that value, and just a fun way of doing it. This example here is actually invalid, though. And that's because you have to have a system in addition to it because it is a codable concept. And then here, you can see we get around it by doing things like adverse event, severity required coding, and then we can pick which one from the list, mild, moderate, or severe, without worrying about what the system or code values are, because why would we care? We do try to bring through as much documentation as we can, and I don't know if that'll find everything. Oh, there we go. So we can see that we have codings, and it has all the comments from the FHIR spec itself. So I know I am getting even shorter on time. So the basic validation, I'll just mention, it does, like we said, a bunch of things on the screen, cardinality requirements, value type checking. Coming soon, we'll have the invariant testing. I haven't implemented it yet, so it's not there yet. But it reports these in operation outcome issue format. So as you do these things, and I don't know if we have this still running. Oh, we do. So if we paste in that invalid example from earlier, we can see that we get back invalid code, adverse event, severity, adverse event severity, type codable concept is missing code required binding to adverse event severity. So the idea is that it can give you those kinds of hinting and kind of best practices for checking our data and making sure things are valid. It's not perfect. You know, there's a lot of things left to do in this project, obviously. And we're discovering all the time when we do it, but you can install it, play with it. Feedback is more than welcome. Also, pull requests, if anyone feels like working and contributing, those are even more than welcome. And then some to-dos here, just talking about, yeah, there's a bunch of things we know we want to do. Internal 64-bit int support, putting the specification info into models so that you can use them in UIs, the custom JSON serialization and parsing, all that kind of stuff. So more to do, but already I'm using it in some internal projects, and it's working well enough so far. So with that, I think we have time for a couple questions yet. Though I'm not sure.
Well, not a lot of time, but is there anyone here? Can you step forward, please? Oh, Axel, please first. Here's the mic.
A question on the date times and
yes.
How do you handle date times? Is it the string which is formatted, or is it like a date time object?
Yes. The first pass right now just has the string formats. It does check the regex to make sure it's valid, and then I have I've been playing out with different code to say, do we just return it? It's isolated its own primitive type, so it's very easy to add all these things. For instance, all the string types, I promote all of the length and value of and all those types of things, so that if you do the length of a FHIR string, you still get the length of the string value instead and all that kind of stuff. So dates is a tricky one though, and I wanted to make sure I got it right, and DevDays came up a little faster than I'd hoped it would. So.
Hey, thank you.
Yes.
This looks really awesome. I can't wait to play with it after several days of email when we get back. Do you have like a recommended pattern for implementing profiles as classes?
A recommended pattern for profiles. So it's one of the things we've been playing with, and actually we're doing another Birds of a Feather on .NET, doing profile type stuff right after this actually. An ad hoc one, so it's not even on the schedule. But yes, the idea here is that we'll be able to generate NPM packages specific to the IGs. So that's why the namespace here we're using right now, you can see it's at FHIR TypeScript, so everything's scoped in there. And then this is R4 core. And that way we'll be able to start adding packages like R4 US core as an IG. And some of the naming we haven't obviously decided on yet.
You want PRs to do that, basically?
Sorry, he was asking if we wanted PRs to do that. If you have an example of what you want to look like, that would be great to submit. And then we have to add it to the code generator because I don't want to manually do all of the IGs. We want to just have it work with the code generator. And so I'm happy to do that translation though. The code generator project is also open source, also on GitHub, and also something I maintain. So. But I'd be happy to add those in, and if you have those examples, that helps a lot because then I'm not writing the code generator at the same time I'm deciding what the output looks like. So that kind of stuff is very helpful.
Okay, well, Gino, thank you very much.
Thank you. Thanks everyone.
For the pull requests, and see you at the next session.
All right. Thanks. Cheers.